There are some of the most spectacular railway stations in France, boldly imagined by ingenious architects and engineers. 3 colossal monuments, 3 multimodal platforms built in France's largest cities to serve millions of passengers.
Stations became exceptionally important as they are gateways to cities.
These state-of-the-art stations brim with technological innovation. In Lyon, Saint-Exupéry Station resembles a bird spreading its wings. Its defining feature? The Tube 300, designed for TGVs racing through at full speed.
There is a slipstream effect when a train comes through at 300 kilometers per hour. It lasts a few seconds and is very strong.
This sort of central corridor was the strictest constraint we had.
In Strasbourg, an enormous glass dome encases the entire facade of a station built by the Germans in 1883.
This monumental glass shell is a giant bubble that both hides the historic facade and protects it.
The idea was to use carved arches connected using a system of spokes.
There are 200 settings for these cables to be properly adjusted and for the shell to hold up.
In Bordeaux, an enormous 17,400 square meter hall seems to defy gravity.
This glass roof is huge and truly striking.
57 meters is 5 times the width of the nave of Notre Dame.
It weighs more than 1,000 tons, roughly 1/5 of the weight of the Eiffel Tower. It's a huge amount of metal.
These 3 prestigious railway stations have distinguished themselves as architectural triumphs, addressing current needs while continuously modernizing.
It's a strategic station, the bridgehead of a high-performance railway complex.
When this glass roof was built, it was the largest in Europe, perhaps even the world.
Strasbourg, Lyon, Bordeaux. Come take a journey through France's most captivating railway stations. 3 monumental and modern designs that celebrate the history and glory of train travel while changing the face of urban architecture.
Before the advent of railways, people traveled on horseback, by horse and cart, by stagecoach, so it would take days and days and days. Crossing France would take several weeks.
From the 1820s, the advent of railways led to a revolution, especially in the amount of transport. A horse on a road can pull 500 kilos. A locomotive on railway tracks can pull 50 tons. It's absolutely huge.
The first French railway line for freight transport was created in 1823 between Saint-Étienne and Andrézieux, 15 kilometers away, but there was no traveler station. It will take another 15 or so years for the first real station worthy of its name to appear on the site of what is now the Place de l'Europe in Paris, near Saint-Lazare Station, the first of many.
There is a fortune to be made, and everyone is investing. At the time, this was called the railway fever, and it affected every parliamentarian, businessman, and banker.
On June 11, 1842, to supervise the nation's railway routes and infrastructure funding, the government of Louis-Philippe I enacts a new law. It will turn the architecture and economy of cities upside down.
The law of 1842 provides for the construction of a network coordinated by the state. Competing railway lines are forbidden, and routes are decided based on the real demands and interests of each region. It's not about anarchy and short-term profit.
Each company is allocated a sector exclusively and by proper concession.
Operation of the railways is delegated to 6 private railway companies whose networks are disconnected from one another so that they cannot merge and create a monopoly. These networks form a 5-point star centralized in Paris and serving all of the country's strategic and commercial points right up to the borders. The Le Grand Star.
The Le Grand Star is a geographical star that helps serve the different regions of France, each line culminating in a major city. Lille in the north, Strasbourg in the east, Lyon in the southeast, Bordeaux in the southwest, Rouen and Le Havre in the west.
The star-shaped network will lead to a proliferation of regional stations, some of them true megastructures and symbols of modernity, from the 19th century until today. In the Gironde in southwestern France, Bordeaux Saint-Jean Station is located in the heart of the city. A cornerstone of the city's railway system, it connects to Paris in only 2 hours and 4 minutes and registers almost 40,000 daily travelers.
Saint-Jean Station has been critical to Bordeaux, particularly from an economic point of view.
It's a prestigious building, a reference in terms of urban planning, in the same way as a cathedral.
The 19th century facade is an architectural gem, spanning 300 meters. But more importantly, it's the XXL surface of its colossal hall that distinguishes this station from any other. The intricate metal structure stretches over 17,800 square meters, the equivalent of 3 soccer pitches.
When this glass roof was built, it was the largest in Europe, perhaps even the world. This hall will also grant Bordeaux Saint-Jean its status of Great Railway Monument.
Yet, in the mid-19th century, the exceptional fate of this building is far from obvious. Indeed, when the Perret brothers, 2 powerful businessmen, decide on its construction, Bordeaux is already served by 5 railway companies.
Bordeaux is a city with an incredible number of stations. In 1956, there are 14.
When you create a map, you see a true constellation, an extraordinary spider's web.
The most powerful network is Paris-Orléans, which focused on the north bank of the river and Bastide Station to connect to the capital, a very profitable destination. Midi Station will be the railhead of the network provided for in the 1842 law to connect the Atlantic Ocean to the Mediterranean via Bayonne, Toulouse, and Sète. One of the most ambitious and risky French railway projects of the mid-19th century.
They will create this cross-country network that seemingly escapes Parisian centralism. It's outside of the Le Grand Star. It's a very curious network, specialized in secondary mountain lines.
The Midi network is not a very profitable network, of course. It's more of a local network for the transport of freight. They are not industrial, but agricultural regions.
In 1852, when the company wins the concession of the line towards the Mediterranean, the aim is to build a monumental maritime station along the south bank of the Garonne.
The precise location of the station will be the subject of much debate and local opposition. Large plots are required to build the station. It's more than just a passenger building. It's freight warehouses, repair shops. This is the start of the line.
After fighting to find a location, a temporary site is chosen. La Paludette, a former insalubrious rural district with swampy and sandy soil, at the junction of the lines arriving from Sète and Bayonne. For the company that needs space, the expropriations are easy and cheap.
It's the best located site to continue towards Sète, the Pyrenees, and all of the Midi.
At the time, the future location of Saint-Jean Station is a swamp. There's a huge sandbank. Then there are the vineyards of Saint-Vincent-Chapelle that will be covered by tracks. It's not an easy location, but at least it has the advantage of being relatively flat.
In 1855, the company will therefore opt for the construction of a temporary terminus station made out of wood for economic reasons.
Bordeaux's first station is therefore a very simple station, built in the style of the time. There must be 5 or 7 windows and doors on the second floor. It's a very ordinary station.
Terminus stations pose 2 main problems. The departures and arrivals buildings are separate.
You had to walk around the tracks, over the railway crossings, which were often closed due to maneuvers. And worse than that, it was often flooded, meaning the people missed their trains. It was a disaster.
This configuration also involves turning the locomotives around as they have reached the end of the line.
There are many disadvantages. When they arrive, the locomotives are facing the stop blocks. Numerous maneuvers are required to free the train and pull it backwards so that the locomotive can change tracks using a switch and return to the depot where it can stock up on coal, water, get service, etc. It's a very awkward situation.
After constructing the building, the Compagnie du Midi hastens to connect its networks to the other Bordeaux stations, which it has acquired, in order to focus on its new station. But there is an even greater issue at stake.
The Perret brothers must make their station important. It must connect to the north. But that's tricky if it doesn't connect to the capital.
5 years later, in 1860, a revolutionary civil engineering structure solves the Perret brothers' problem. A metal bridge over the Garonne connecting Midi Station to Bastide Station on the north bank.
Until now, passengers arriving at Orléans station from Paris had to cross the stone Pont de Pierre and pay a toll. You can imagine how difficult that was with luggage. It was long, tiring, and tedious.
At the planned site, the river is 460 meters wide. The bridge, however, will have to stretch 510 meters in order to span both the river and the road on the right bank. A challenge taken up by a very talented young engineer, Gustave Eiffel.
The river is fast-flowing. The riverbed is unstable, swampy, sandy. For Gustave Eiffel, there's no doubt puddled iron is the most suitable material to build a bridge that will be described at the time as light. The riveting, the choice of an open-work bridge, are all elements that characterize the modernity of this bridge and are in line with the wishes of the Perret brothers.
Eiffel introduced the deck technique, the deck being a sort of cage with cross braces. The cage was built on one of the banks and was then pushed over the piles using roller bearings. The cage was pushed along and put in place.
In order to support the passing of trains, 2 rail tracks, as well as a lateral footbridge for pedestrians, a 9-meter wide, 553-meter long, and 3,000-ton metal deck will rest on 12 piles deeply anchored in the bed of the Garonne.
The boring of the piles in the river was a particularly difficult stage. Eiffel's idea of adding hydraulic presses, allowing the artisans to work below water level in hyperbaric chambers, is a true technological advance that allows them to meet the deadline.
The principle of hydraulic pressure boring is simple. A metal cylinder is sunk into the river's alluvium. It is separated into 3 horizontal compartments, the middle one serving as a surge tank. It is watertight and pressurized by a steam engine, producing compressed air to balance the pressure with the water outside. The water in the lower compartment is driven out, making room for the workers to dig into the riverbed before pouring the concrete that will form the pile.
It's a very modern bridge insofar as there are very few piles compared to the stone bridge with its very heavy masonry. It was a revolutionary structure because it was light and solid compared to previous constructions.
On August 5, 1860, after completion of the work, the Midi network, headed for the south of France, is connected to the Orléans network.
The bridge rewrites the future of Midi Station, which is no longer chocked by these stop blocks. Trains can finally pass through.
Suddenly, Bordeaux Saint-Jean Station becomes a link in a national network, and not just a regional one, simply because it now directly connects the Midi to Paris.
The flow of travelers after the construction of the bridge changes completely. It's a flow of businessmen. There is also high migration from poor rural areas towards major cities.
Between 1830 and 1865 in France, the success of railways is such that the number of travelers rise from 2 million to 84 million per year, more than double the population at the time.
The success of the railway will be tremendous, and very quickly, the old Padodat station will be overwhelmed and inadequate.
With 450,000 yearly travelers, Midi Station rapidly supplants Bastide Station, even though it is absolutely not equipped to deal with such a flow of passengers. Yet the building that was only supposed to be temporary will last 40 years.
Faced with the increased number of travelers, the Compagnie du Midi will play the train length card. Trains will go from 4 to 5 cars to 15 to 20 cars and will transport more than 1,000 people at once. But it's mayhem in the waiting rooms and ticket booths.
There is a huge increase in pressure, which raises the question of rebuilding this station.
In 1872, pressed by Bordeaux officials and Parisian authorities, the Compagnie du Midi is finally forced to design a building that's fit for purpose. The project of the station as we know it today is underway.
They called on Marius Toudois, an architect who has already worked with the company on other stations.
Toudois designed the new Gare de Lyon station for the World Fair. He's a very popular architect at the time, with his own signature, his own style. He knows how to design stations.
But it will take 17 years and about 20 projects before any of them materialize.
For the Compagnie du Midi, of course, the Bordeaux-Saint-Jean railhead must be able to compete, or at least be on equal footing with Parisian railheads. Paris has many beautiful stations, and so Bordeaux can't possibly be less impressive.
On July 23, 1889, construction begins. This is a through station with 7 tracks for travelers, as well as around 20 others for maintenance and freight.
The new Bordeaux-Saint-Jean station is a brand new station, a through station, as we are definitely on a through route. And so this station is bound to be asymmetrical, one main building on just one side of the station.
The main building with its monumental 300-meter-long facade along the platforms is made up of 3 sections. The middle section is home to a buffet and the hotel. It separates the departures in the north and the arrivals in the south.
The Great Hall, the Great Foyer as it was known at the time, is huge. The Great Hall of the Opera fits inside it. At the time it was built, it was one of the largest halls in Europe.
As they enter the departures hall, travelers head towards the ticket booths in the Great Foyer to buy their tickets. They are then relieved of their luggage before being invited to wait in the waiting room, which is closed until the train departs for safety reasons. Arriving travelers exit via the south building after retrieving their luggage.
In France, we want to control travelers. We want to ensure that the flows don't meet, exactly as in airports today. We're quite worried about the unruliness of crowds.
To shelter both travelers and trains, the impressive hall and its monumental glass roof are inaugurated in 1898. Its ridge culminates in 26 meters with a length of 300 meters and a width of 57 meters. A true feat in 19th century Europe.
This glass roof is huge and truly striking. It becomes a bit of a celebrity in Bordeaux. It's almost all anyone can talk about.
It's an emblem for the city, much more so than the stone architecture of the building itself. It reflects the energy of the city.
The metal frame carrying the weight of the huge glass roof was designed with 31 curved trusses at 9-meter intervals and 2 further trusses at either end. They are supported by the beams and multiple hanging connectors that help reduce the stresses. They rest on the building thanks to ball joints on one side and a line of metal pillars anchored in the foundations on the other. This configuration enables a very wide opening of 57 meters.
We admire cathedrals, but cathedrals only span 11, 12 meters. They're made of stone, but 57 meters is 5 times the width of the nave of Notre Dame.
The decision to build large halls, perhaps even too large by today's standards, is based on the desire to free the platforms of any pillar that might hinder the movement of crowds.
These glass roofs are bold, and metal architecture is freed from the constraints of stone architecture.
But how does one reach such a span without risking the structure collapsing under its own weight?
The evolution of metallurgy enables the production of increasingly longer and finer elements. Before, there had been structures in cast iron, then in puddled steel, in steel. Riveting, which is another new process, enables the assembly of these elements. So, it's a whole evolution that leads to increased resistance, which didn't exist beforehand.
The overall structure of Saint-Jean Station weighs more than 1,000 tons, around 1,200 tons, roughly 1/5 of the weight of the Eiffel Tower. It's a huge amount of metal. But this design is very sound, very long-lasting, very resistant, and that's why, a century later, the Great Hall is still standing.
While this extremely sturdy structure is able to support significant loads, it is not the only constraint taken into account by the architects. They also had to anticipate climatic variations.
Metal, depending on the ambient temperature, contracts or dilates. It's constantly in motion. And so, to spread out these stresses that are very different from one another, we have a trolley system, perpendicular to the supports, like casters on tracks, that can withstand a certain amount of flexion in order to maintain balance at all times.
In order to carry out the vast project of the hall, the engineers designed a huge 400-ton wooden scaffold.
At the time, the requirement was clear. Traffic wasn't to be interrupted, so everything was assembled whilst the trains continued to run. They built a wooden frame that matched the height of the hall and could be moved along tracks of its own to follow the construction of each section. And on it, there was a hive of workers to assemble all the parts.
To expedite the work, part of the scaffold was located upstream of the truss to be put up, the other perpendicular to the section. The metal parts of the trusses arrived in pieces on a dedicated track and were placed one by one below the lifting devices before being hoisted to their exact assembly location.
We have this kind of sequential construction of the hall, which also helps to expedite the maneuvers and to reduce the number of scaffolds or temporary constructions as the job progresses. For the glass roof, we can see that, as with any project, any innovative industrial construction at the time, the engineers learn as they go. In '96, it takes them 12 days to install one of the trusses, whereas when they finish in '98, it only takes them 5 days.
While these glass roofs are elements of prestige and comfort for passengers, they turn out to be just as costly to build as to maintain. In 2015, 117 years after its inauguration, that of Saint-Jean Station was entirely renovated as part of a gargantuan project.
Choosing to preserve and renovate these great halls for them to last is not always that easy. Many stations have seen their great halls disappear. The Great Hall renovation project aimed to tackle every element of the Great Hall to ensure it returned to optimal operation. All the roofing elements were heavily damaged, and there was a huge amount of water ingress. This left the metal bare, which started to corrode and therefore to lose matter. The entire roof needed replacing. That's 20,000 square meters of soffit made up to 2 layers of wood, painted in white, and zinc panels on top. There was also 10,000 square meters of glass panels to let the light into the station.
But how to carry out such an undertaking while respecting the original building plans and the architectural canons of the time without disrupting rail traffic?
The project's first constraint was that it had to be finished in time for the arrival in Bordeaux of high-speed trains in July 2017. The second constraint was to carry out this project while still welcoming travelers, with no impact in terms of transport, that is, without canceling a single train. The third constraint was related to resources, since we are talking about evacuating colossal amounts of used materials containing asbestos and lead and bringing in equally colossal amounts of new materials.
To this end, a scaffold, much more impressive than the one required for the construction of the hall in the 19th century, was thought up by the engineers. A colossal 2,400-ton mechanical structure onto which an 18,000 square meter platform was installed, 26 meters above the tracks and overhead lines.
Above this first scaffold, we created a plank platform, a new floor that served as a base for the project, onto which we installed tracks, new tracks above the tracks, along which we could slide new scaffolds in order to enable those who needed it to travel along the station's 300-meter length.
After 30 months of work, 25,000 liters of paint, and a new zinc covering, Saint-Jean Station, listed as a historical monument in 1984, finally regains its luster of yesteryear.
Bordeaux Saint-Jean Station is a kind of anchor point that embodies travel technology, including high-speed travel, while also embodying a certain monumentality that is now an integral part of the city. It's one of the great monuments of the city of Bordeaux, a monument of 19th century modernity, which today has taken its place while adapting to new uses.
More than 134 years after its inauguration, having successfully adapted to great changes in the railway sector and accompanied the evolution of the city of Bordeaux, it remains one of France's most beautiful stations. In eastern France, in Strasbourg, another station with an exceptional glass structure has encountered an extraordinary fate: Central Station.
This station was a great leap into modernity.
It's an exceptional technological tool.
As the third largest station in France outside Paris, more than 20 million travelers pass through it every year. The important railway network at the heart of which it lies serves Paris, Marseille, and Stuttgart.
It's a strategic station, a passenger station, a freight station, a shunting yard, the bridgehead of a high-performance railway complex.
The passenger building, built by the Germans in 1883, with its neo-Renaissance facade decorated with sculptures and stained glass, hides beneath a huge glass shell designed to double the floor space and connect the underground tram station below.
It is monumental, delicate, spectacular.
An architectural feat that made it possible to deal with the boom in travelers following the opening of the TGVs line in 2007.
Organically, a station is about network architecture, but a network constantly has to modernize, or it becomes obsolete.
When we started thinking about how to welcome travelers when the TGV arrived, we realized that there were two main issues to solve. The first was the lack of space. We were going to welcome around 20,000 extra travelers per day. A traveler with a suitcase occupies around 2 square meters. So we needed 4,000 to 5,000 extra square meters to cater for these travelers. The second issue to solve was that the various means of transport arriving at the station arrived outside, in particular the tram.
The architects were faced with a kind of dilemma, a contradiction: how to preserve its monumental pink sandstone facade while reconciling the creation of new spaces capable of dealing with larger crowds.
Not only is the station enclosed, but its facade is listed as a historical monument. The walls are therefore off-limits when it comes to extending the passenger building. To solve this difficult equation, the SNCF will call on its architecture firm, which since 1986 has laid the foundations for designing major contemporary stations in France.
This building, which is emblematic of Strasbourg, is going to be treated like a very precious object. It's going to be placed under a dome, a large glass structure jutting out about 14 meters at its deepest, in front of the station, just to collect passengers arriving by tram.
It wasn't about attaching the shell to the station's historical stone facade.
A self-supporting glass shell, like in Strasbourg, is really about adding a new element while totally preserving the existing element.
For the metal frame not to touch the facade, it is made up of 16 independent pylons, deeply anchored in the ground, from which run as many main steel arches and dozens of other fine ones. Like a bicycle wheel, the curvature is maintained using a system of cables radiating from a central hub. The whole is covered in 900 panels of laminated glass.
At first, we thought we could cold bend this glass because glass is flexible. But in this case, to avoid travelers being showered with glass if it breaks, the glass is laminated.
Just as in car windshields, laminated glass is made up of 2 sheets of glass bonded to a plastic film between them. It offers better shock resistance and added safety in the event of breakage, but it is harder to bend.
If you try to bend it, the inner glass has a shorter radius than the outer glass, and it doesn't work. So we had to hot bend it. We studied the curve of the shell to have just 3 molds of circles with varying radiuses to fit in the furnace.
To prevent air and wind infiltrating between the 2 structures, the glass shell is equipped with a brush seal resting delicately on the wall, and the water is evacuated by channels on the original building.
When you build a structure like this, it's completely new. We've never done this anywhere else.
All these processes, very innovative at the time, provide for the possibility of freeing the historic facade of the structure if necessary. But how does this glass shell, seemingly so light, resist the elements?
Often, to make structures more resistant, we use what we call diagonal crosses, cables that stop them moving. But we thought if we use them in 2 sections, it's going to break the continuity of the glass. And so we used very fine cables running from one end of the shell to the other, everywhere, in both directions. When the wind blows, these cables have to resist different stresses depending on the section. So we had to adjust the cable tension of each section. There are 200 settings for the shell to hold up.
Another specification to comply with: ensure that the old station is visible from the outside, depending on the light.
We contacted the Scientific and Technical Center for Building, which has software that simulates reflections at different times of day. And so, we modeled the facade, and we saw the times when the glass reflects the light, and those where you can see through it. The result, I think, is quite convincing, insofar as the glass is totally transparent at night, thanks to the lighting. And during the day, we have this dialogue with clouds reflecting in the shell, creating a new urban event, which I think is pretty good.
After 2 years of work, the extension requiring 650 tons of glass and steel optimizes the station's functionality. It brings together access and traffic areas, leaving the various services to the original building. In 1852, at the beginning of its history, Strasbourg Station is far from being a modern building. Set up along the canal inside the historic city walls, it is operated by the Compagnies du Chemin de Fer connecting Paris, Strasbourg, and Bâle. But only 16 years after its inauguration, a tragic event precipitates the course of its history. On September 28, 1870, the Prussian army seizes Strasbourg and the whole of the Alsace-Lorraine.
In 1870, the war goes wrong for the French army. Strasbourg is besieged and bombed for a month and a half, extremely harshly and brutally by the besiegers. The old station is actually partly destroyed. The cathedral is bombed. Strasbourg Library goes up in flames, and it's a wounded city that is annexed by the German Empire.
With Bismarck's victory, Strasbourg suddenly becomes the capital of the imperial territory of Alsace-Lorraine. The Reichsland has huge ambitions for the region it has just annexed.
The Germans have many amends to make to the citizens of Strasbourg after destroying large parts of the city. They therefore want to make it a capital that showcases German power, but also German modernity and German culture. And so they invest a lot in Strasbourg's development.
The city destroyed by bombs will be rebuilt and extended around its historic center as part of a vast new town project that will triple its surface area, the Neustadt.
Central Station is the first project designed to modify and modernize the city because, in military terms, Strasbourg is obviously extremely important.
France wishes to recover its lost provinces, and the Germans know that. Sooner or later, there will be another war against France, and so the railways play a strategic role in the transport at any moment of troops and weapons.
The old station, located on a narrow plot of land, cannot be extended enough to meet the needs of the empire. It will therefore be moved to the western part of the Neustadt.
The new central station will cover a surface area of around 37 hectares in a new town of 400 hectares, meaning it occupies a very important place. It is a very strong symbol of belonging to the German Reich. It's a strategic station.
They simply razed the old fortification, erected the station in this location, and then protected it with a new fortification.
Work begins in 1878 with the construction of a through station. 150 meters long, 17 meters wide, and 24 meters high, flanked by a double metal hall sheltering the platforms at the back.
It's a building that looks more like a Florentine palace than a train station, because there is no belfry, no big clock, no structure really that lets on that it is in fact a station.
The passenger building was constructed in 2 years, which is a very short time, thanks to the use of new materials, including very large metal structures. Indeed, the ceilings, in particular that of the main hall, is made out of ribbed zinc with a whole system of crisscrossed metal beams. The ceilings of the underpasses are vaulted I-beams. They are materials that help gain in lightness, but also bear very heavy loads.
The other defining feature of the station is its unusual two-level layout. Travelers are welcome and sorted in a monumental single-story departures hall. Behind it, a series of hallways and tunnels support the platforms and tracks located on the floor above.
To do this, we had to create levees, embankments. So some of the platforms are raised, level 0 being the ground of the square and the passenger hall.
The advantage of a two-level construction in terms of traveler flow is that it allows for the total separation of incoming and outgoing travelers, meaning that they never meet, since they are welcomed in different tunnels, and this allows for a significant flow of travelers.
In addition to the raised platforms, there are also lower platforms level with the ground.
Lower platforms intended for freight and military transport located behind the two glass roofs, a condition imposed by the Army in order to facilitate the landing of troops arriving from Germany in convoys.
The lower station has several functions. There were tracks towards large freight warehouses, customs buildings, and the depot where the locomotives were stored. In total, there were 92 tracks between the upper and lower stations, which is huge.
All these tracks enter into the city itself via two railway tunnels located in the fortifications north and south of the station. To prevent any foreign intrusion inside the walls, armored doors secured the entrance of the tunnels.
The station is a political manifesto that Strasbourg and the Alsace-Lorraine belonged to the Second Reich, and it's also a manifesto of German greatness at the time, since Germany had access to the latest technologies when it came to electric lighting and central heating, and because it was energetically self-sufficient.
The issue of electricity is related to that of modernity. In the late 19th century, most of the population still uses wood or coal stoves for heating, as well as candles and oil lamps for lighting.
On August 15, 1883, when the station is lit for the very first time, it's so spectacular that locals will stay on the platforms until midnight to really feast their eyes on this new marvel. The electricity ferry has arrived in Strasbourg.
Designed to showcase German technology, Strasbourg Station is a one-of-a-kind building. While reminding residents of the tumultuous history of the city returned to France after World War II, it also underlines its energy and ability to modernize.
It is a station that has overcome history, that has overcome transformation.
From a simple terminus station in 1854, Central Station has become a vast multimodal hub. An interface between train, tram, road, and new mobilities, it has successfully adapted to the massive increase in passenger flows, launching itself into the 21st century.
It is a successful station because it has stood the test of time and is part of a visionary concept. And that's what makes the quality of a station, being able to anticipate future needs and to adapt to an evolution that even its creators couldn't have imagined.
Further south, in the Auvergne-Rhône Alps region, 20 kilometers outside Lyon, Lyon Saint-Exupéry Station embodies the late 20th century train revolution. It's the first TGV station in France.
Saint-Exupéry Station, formerly Satolas Station, is a totally new and original station in the history of French stations. It's a first.
Saint-Exupéry is the birth station of the TGV system, the nation's destiny.
Akin to a bird taking flight, this reinforced concrete structure, covered in a steel roof, is 120 meters long, 38 meters high, and 100 meters wide. It is used every year by almost 2.5 million travelers headed to Paris, the Rhône Alps region, and Provence.
The station is like a giant enigma. When you look at it, you wonder how it all holds up.
More than a station, it's a multimodal hub, a bold construction whose story begins in 1986. At the time, the TGV is a success.
Satolas Station is part of a large movement generated by the development of the TGV, which led to a true transformation of train stations.
In the 1980s, the SNCF chooses to spare no expense on passenger transport by offering a new, much faster way to travel, and suddenly distances and travel times are almost halved.
As part of its modernization program, the SNCF decides to prolong its first high-speed line, Paris-Lyon to Valence. To save time, the line must bypass Lyon 20 kilometers to the east, enabling the TGV to continue heading south at 300 kilometers per hour without decelerating.
Bypassing Lyon has been a major issue for years for the railway industry. It's one of the rare cities in Europe developing towards the east. This route, via the east, is obvious for geographical reasons. Indeed, Lyon backs onto mountains on the west side, so bypassing the west is almost impossible.
Another advantage of the eastern TGV route, the presence of a plain where Lyon-Satolas Airport was built in the 1960s.
This airport plays an important part in connecting the city of Lyon with the rest of France, Europe, and even the world.
Connecting the airport in this location is important for the TGV because, in the 1980s, it is in the SNCF's interest not to see aviation as a competitor, but instead as a complementary, by building tracks and platforms wherever there are airports. They are the future.
In the specifications, several constraints must therefore be combined: direct and fast access to the existing airport, but also creating a structure in which some TGVs can stop while others can pass through at full speed without disturbing waiting travelers. The call for proposals launched in 1989 among the world's most avant-garde architects is one by Spain's Santiago Calatrava.
I was aware that I was in a unique position. On one hand, a region seeking an identity, and on the other, a clear concept of connecting the station and airport. This means you can arrive in a city and travel from its airport to the next airport across a whole network of local lines.
To meet the requirements, the architect will design a station in a trench, akin to a bridge crossing the high-speed line separating Lyon from the airport.
We can consider this station as a bridge station, insofar as the hall is level with the ground and the platforms are several meters below. The main advantage is that it means that we don't see the whole system of overhead lines, but only the superstructure of the Great Hall, which makes the whole a lot more expressive.
On either side of the hall, for stopping trains, platforms as long as 2 TGVs, 400 meters sheltered by a light covering, crossed at each end by a road bridge, providing access to the airport. A structure inspired by a sculpture designed by the architect 10 years earlier.
The original concept of this sculpture, you see, is very simple. Architects work with their eyes, and this is a tribute to the eye.
But how did Santiago Calatrava graduate from a 70-centimeter sculpture to this colossal structure?
This building is very simple because you have arches spanning the station, and on top, there is a large, slightly tilted facade, and above that, there's a roof with a very large overhang.
The structure is made up of 6 arches, 2 in concrete spanning the floor slab of the hall, and 4 in steel, 100 meters long, supporting the weight of the bird's crest, as well as that of the 2 huge overhanging wings. At the back, they rest on concrete blocks that are deeply anchored in the ground and meet at the front where all the forces concentrate to form the entrance of the station, the bird's beak. On either side, 25 beams bolted to the concrete arches make up the north and south facades, covered in glass to enclose the hall.
The idea of an obvious frame is really to express the stresses at play, to show that in a particular place there is a huge stress and therefore more matter. It's very curious because in Saint-Exupéry Station, it's the structures and their expressive power that bring the station to life. It's more than just a shape, since they express forces that pass through matter.
Inside the huge volume dedicated to travelers, 2 large overhanging terraces jut out into the hall.
In architecture, what's always surprising about an overhang is that it's a surface that seems to be floating in the air, but with no effort, as if it were flying.
An overhang leads to a very modern perception. It means things can jut out, and you can also have more lightness instead of always having pillars, etc.
To create these large overhangs, there are counterparts with very particular shapes, structures that can take the stresses of the overhang.
At the back, the services are hidden in a small building adjoining the main structure, from where a footbridge departs, directly connected to the airport terminal. And below the infrastructure, 5 sets of dugout tracks, 3 alongside the 2 platforms where the TGVs stop, and 2 in the middle for direct trains. The latter are enclosed in a tunnel, the Tube 300, to protect the station from the shock wave of TGVs passing through at full speed.
The SNCF wanted a through station, but without having to slow down trains. This requires a station through which trains can pass without stopping. And when a train passes, even if it slows down to 250 kilometers per hour, it creates a real shock wave that you can feel physically.
When a TGV enters a closed tunnel, it pushes air into it. There is excessive pressure in front of it, and so you have to create vents to allow the pressure to be released. This sort of central corridor through which trains can pass was the strictest constraint we had, and we built the entire station around it. And we tried to combine these two flows, the flow of trains and the flow of people.
Instead of enduring the tunnel, the architect placed it at the heart of his plans. Made out of rough concrete, it supports the structure on which the roof rests and serves as a connection between the platforms and the hall, accessible via an array of escalators and elevators.
You cannot do without concrete. It's a historical material. The Romans used it. It's a material that can take shape. And in my opinion, it's its plasticity that makes it so interesting in modern times.
It can be molded quite easily, so you have a great variety of shapes. It's resistant because it contains metal reinforcements which enable it to resist friction and overhangs. So concrete is quite a universal material, and we may not yet have exhausted its potential.
Calatrava and the SNCF engineers successfully delivered a building with a unique visual structure and whose architecture perfectly meets the needs of high-speed trains.
Saint-Exupéry Station is a monument that marks an era. It's a major building for French architecture.
Major French railway stations have become heritage buildings in the same way as major churches, chateaux, and other prestigious buildings.
Be it Saint-Jean Station in Bordeaux, Central Station in Strasbourg, or Saint-Exupéry Station in Lyon, French stations have tackled the continuous increase in railway traffic. Some have undergone exceptional transformations during their history, adapting to steam engines, electric traction, and finally modern high-speed trains.
The importance of railway stations needs no further proof. They have, in fact, remained so important that the SNCF had the idea of using them to boost cities. Stations have become shopping malls, places people visit. Every day, there is an astonishing number of people who pass through stations, millions of people. Stations are also fundamental in the everyday life of many people. They help us, if you like, feel closer to one another, not only from a purely functional point of view, but from a symbolic point of view too. They will remain extremely important assets for generations to come.
Like 21st century cathedrals, railway stations have become truly emblematic monuments. Bustling spaces in which we take the time to stop and are today an integral part of French heritage.